SGM College, Kara. See, in this lecture today we are going to start physics. From that physics, our first chapter is the rotational dynamics. But from that rotational dynamics, today I am going to start vertical circular motion. So, we are going to start vertical circular motion. But before starting that vertical circular motion, we have to revise the some part. In that first of all, first definition is there, circular motion. That first definition we already learned at the beginning of that chapter. See there, we know what is the definition of circular motion. See there, the motion of a particle along the circumference of a circle is called as the circular motion. In that, very important thing is that circle having a fixed radius. The motion of a particle along the circumference of a circle is called as the circular motion. Here, r is the radius vector. That radius vector is directed away from the center of a circle. Already we learned that circular motion. But if you are going to see vertical circular motion, so I want to revise that circular motion. In that, r is the radius vector. Radius vector means that r required magnitude as well as direction. Then second component is the theta. Theta is angular displacement. Next component is angular velocity. And last component is its angular acceleration. We know all these things, but still we are going to revise. R is the position, R is the radius vector, otherwise it is a position vector. The line segment which joins the position of the particle along the circumference of circle to the center is called as a radius vector. That radius vector is directed away from the center of the circle. Next one is the angular displacement. As the particle is going to change its position, that time we are getting the angle theta. That angular displacement is the angle made by the radius vector with the center is called as the angular displacement. Next component is the angular velocity. Angular velocity is nothing but the time rate of change of angular displacement with respect to time. And last one is the angular acceleration. Angular acceleration is that time rate of change of angular velocity with respect to time. Already we know that. Again we have to see the types of the circular motion. The circular motion is divided into two types. First is the uniform circular motion. And second one is the non-uniform circular motion. There is a basic difference of that uniform circular motion and non-uniform circular motion. So, here we are taking that point. See that the motion of a particle along the circumference of a circle with a constant speed is called as a uniform circular motion. A body which is going to revolve along the circumference of a circle, but the speed is constant, that time the motion of that body is called as a uniform circular motion. That means in the case of uniform circular motion, the speed remains constant. But in non-uniform circular motion, the motion of an object along the circumference of a circle with a variable speed. In this case, the speed of that particle which is going to perform circular motion is changing. So that means here speed is not a constant. I want to remind you, we know for the creation of a circular motion, the initial velocity and force should be act on that particle. Which particle is going to perform the circular motion? In circular motion, see there, suppose we are drawing such diagram also. In that circular motion, when the particle is present here, that time the tangential velocity is present for that particle. What is meant by the tangential velocity? It is that arrow which shows the direction of the velocity of the particle. That particle is going to perform the uniform circular motion. In that, velocity is constant, but very important thing is there in that velocity, magnitude of velocity is constant, but direction of that velocity is going to change. So this is one of the characteristics of uniform circular motion. upward. In this case, magnitude as well as direction, they both are going to change. So this is the main thing for our vertical circular motion. If we are talking about the examples of both that, see here is that when the moon is revolving around the earth, that time the motion of that moon around the earth is a uniform circular motion. We know if there is a circular motion, if there UCM is present there, that time the necessary centripetal should be present there. That necessary centripetal force is given in the case of moon by gravitational force. See, the particle is going to perform circular motion, uniform circular motion. That time the force is acting on that particle and that force is directed toward the center of the circle. We just now said the direction of radius vector is opposite to the centripetal force. That centripetal force is directed toward the center. The force which is directed toward the center along the radius vector is called as the centripetal force. In this case, centripetal force and radius vector, they are opposite in the direction. So, when moon is revolving around the earth in a circular motion, that time the necessary centripetal force is given by the gravitational force which is present in between earth and the moon. Now here, suppose we want to find the example of a non-uniform motion. That time, suppose any object is there, that object is going to perform vertical circular motion. That time we are getting the vertical circular motion. So vertical circular motion is the example of a non-uniform circular motion. See, suppose I want to tell you any example. Suppose we are taking a string. The one end of that string is tied to the stool, and that string we are going to revolve vertically. That time we are getting the direction. That time we are getting the motion. That motion is nothing but vertical circular motion. Now we are going to start the vertical circular motion. First of all, we will see the types of that vertical circular motion. Downward, we will see definition of vertical circular motion. And when the vertical circular motion is there, then what are the details of that vertical circular motion? First of all, I want to tell you that vertical circular motion is divided into two types. First type is there. Vertical circular motion is controlled by gravity. And second part is that vertical circular motion is not controlled by gravity. In this type, the vertical circular motion is controlled by constant speed. Let me discuss about that, and then we will see the example of that vertical circular motion. The vertical circular motion is divided into two parts. First is that the vertical circular motion controlled by the gravitational force. Next one is that the vertical circular motion is not controlled by gravity, but in this case we are keeping the speed constant. If you want to give the example of the second type, vertical circular motion, not controlled by the gravity but by the constant speed, giant wheel is present there. Whenever we are going in the fair, otherwise in Ramoji Film City is there, in Pune, in our childhood there was Asselwood was there. In that place the giant wheel is present there. In that giant wheel, the motion of that giant wheel is the vertical circular motion. It is controlled by the constant speed. Now we have to talk about the vertical circular motion. That vertical circular motion is controlled by the gravity. For that time there are some characteristics are there. Which are that characteristics? In this case, when suppose here I am drawing the diagram of vertical circular motion, I want to show you the vertical circular motion in such a way. It is in anti-clockwise direction. See, we can see it is the uppermost position, otherwise the top position. B is present there. It is a lower position. Here, point C and point D. Here I am drawing the vertical circular motion of a object. Position A shows the topmost position. Position B is the lowermost position. C and D, they both are horizontal position. Otherwise, we can say it is a midway position. See, when we want to send any particle in a vertical circular motion, otherwise to perform the vertical circular motion, At the lower point, we have to give initial energy to that object, then the object is going to perform the vertical circular motion. To perform the vertical circular motion at the lower position, necessary energy should be given. That time the particle is going to perform the vertical circular motion. As the particle is performing vertical motion, afterward the kinetics, otherwise the motion of that body, is controlled by the gravity. In that there is an interconversion in between the energy. The gravitational potential energy is converted into kinetic energy. Okay, so these are the characteristics of the vertical circular motion. These are controlled by the gravity. Now here we are getting the definition of that vertical circular motion. What is the definition? Very simple thing is that already we learned in that non-UCM the direction is going to change. Here at a vertical circular motion, everywhere tension is present. Just now I told you we are taking the string, at the one end of string is tied by the stone and we are going to revolve that. It is going to wheel in a vertical circular motion. If string is there and string is tied to the stone, that time there is tension is present. So at every place the tension is different. At the topmost position tension is TA. At the midway position at point C tension is TC. At the D position the tension is TD, and at the B position the tension is B. When the body is revolves in a vertical circle, then its velocity and its tensions are different at a different point. Then such motion of a body is called as the vertical circular motion. That means a body which is going to perform the vertical circular motion at every instant, the value of tension is changing, the value of velocity is going to changes. Direction also changes. We learn in non-UCM in that magnitude as well as direction of a object which is going to perform vertical circular motion, the both are going to change. So here we are getting the definition is that a body revolves in a vertical circular motion such that tension and the velocity of that body is going to changes at different point. Then such motion is called as the vertical circular motion. Now we are going to see the next point is there. In that the vertical circular motion, in that we are instead of that stone we are taking a point mass. So in that first part is the point mass undergoing vertical circular motion under a gravity. In that two cases are there. In first case we are taking the mass tied to a string, and second one is there the mass tied to the rod. But in that we are learning the first case. Here mass tied to a string. See that just now we have started the vertical circular motion. In that vertical circular motion we learn the definition of body revolves in a vertical circle such that its tension and velocity is different at a different point. Then such motion is called as the vertical circular motion. In that vertical circular motion our first type is there point mass undergoing vertical circular motion under a gravity. That means we are going to learn the vertical circular motion. That vertical circular motion is controlled by the gravity. And here, instead of the mass, we are taking, mostly we are taking the bob. But here, our heading is there, the mass tied to a string. So here we are taking one of the bob, that bob having the point mass. So I will draw the first diagram, then I will explain the diagram, and then we will start the expression. What is our heading? See here. The mass tied to a string. So consider a bob. Here bob we are going to consider as a point mass. That bob is tied to a string. The string which are going to perform the vertical motion, that string is unextensible, it is flexible. Whenever we are starting the vertical circular motion, that time the length of that string is not going to increase. Very important characteristics is that string is massless. Consider a bob which is tied to a string. That string is massless, unextensible, flexible. When the string is performing the vertical circular motion, that time the bob is going to perform the vertical circular motion. Okay, now let me see some parts which are present in the diagram. First is there A. A means the topmost position of a bob which is going to perform vertical circular motion. We can say it is upper position. Second one B. B is the lower position of a bob. Third one C and D. They both are the horizontal position of a bob. Otherwise we can say it is a midway position of the bob. Now as per the definition, in a vertical circular motion, tension changes at different places. Also the velocity changes at different places. So here TA is the tension at point A, TB is the tension at point B, TC is the tension at position C, you can say position otherwise point, and TD is the tension at point B. So here we know in a uniform circular motion, in both uniform circular motion and non-uniform circular motion, the direction of velocity is going to change. Okay, so in that case, here VA, it is the velocity at position A, VB, velocity at position B, VC, velocity at position C, and VD is the velocity at position D. Now see that we have learned about all the points of that diagram. Then we will go ahead. See that, just I want to explain the diagram. See that when the bob, otherwise any object is going to perform the circular motion at any position in the vertical circular motion, the bob, on that bob, two forces are present. What I want to say again, see that I want to say when the bob is going to perform the vertical circular motion at any position of that vertical circular motion, on that bob two forces are there. The first force is due to tension. That force is vertically downwards toward the center. Second force is due to weight mg. That weight mg is vertically downward. It is some places it is toward the center. In some places that mg is vertically tangential to that tension. Here I want to tell you the tension mg. In every cases the force due to weight mg, it is vertically downward and its value remains constant. The weight mg is not going to change. But in the case of a tension, as places changes, the value of tension is going to change. That means the magnitude of tension is not constant. So we can say tension is not constant. But here that weight mg, the force due to weight mg, it is directed vertically downward. That force due to weight mg, it remains constant. Okay, so these two forces are present on the bob which is going to perform the vertical circular motion. Here one thing is that the tension is directed toward the center and the mg is directed vertically downward. The mg is present in vertically downward. As the time goes on, the tension is periodically changes with the time and the location. As a bob is going to perform the vertical circular motion, the time goes on. As the time changes, the value of tension also changes, and as the location changes, the value of tension also changes. Now, here one thing is there. We can see the two forces are present at each and every places, at point A, at point B. See, let me first talk about the 2 points at position A and at position B. The resultant of that two forces is directed toward the center. That means here the resultant of that two forces is a centripetal force, and the resultant of that two forces is directed toward the center only at position A and at position B. But at position C and D, the part of the resultant is a tangential to the centripetal force, and that part of resultant is used to change the magnitude. See what I want to say here, the mg is tangential to the force due to tension. At point D also, weight M, the force due to weight mg, it is a tangential to the tension. So in this case, the resultant at point C and at point D, the resultant is, the some part of resultant is used to change the speed. So these are the total our diagram is there. Here some points are written there. As per our that derivation is going on, I will explain the remaining parts from the diagram. Now, as per the position, we have to find out the velocity at upper position, velocity at the lower position, velocity at midway position. Again, I want to tell you, see that A is the uppermost position of a particle which is going to perform the VCM. See, at point A, the tension is TA, that TA is directed toward the center due to weight mg. That mg is also vertically downward towards center. Just now we said the particle which is going to perform vertical circular motion on that bob, two forces are present there. In that, the magnitude of that weight force due to weight mg, it is constant, it is always directed vertically downward. And next one is the force due to the tension. So the magnitude of that tension is going to changes as per the time, with the time and as per the location. Now see, B is the lowermost position of the bob. On that B, tension T present, that tension is denoted by TB. That tension is directed towards the center and mg is directed vertically downward direction. They both are opposite to each other. Here they both are toward the center. So in this case, the resultant of the two forces is the centripetal force, and that centripetal force is helping for the vertical circular motion. At point B, the resultant of that force is their centripetal force, but at point C and at point D, what happened? The some part of resultant is tangential to the tension, and that part is used to change the speed of the ball. Now we have to see one by one the velocity at the uppermost position, the tension at the uppermost position, as the remaining position, lowermost position, and then we will see at the point C and D. Because C and D are the our midway positions, otherwise a horizontal position. Let me discuss about first uppermost position A. Let me talk about the separately about that fourth position. See that uppermost position, that means A is the uppermost position in UCM, otherwise it is a upper point. Here at that point two forces are present here. First is the force due to weight mg, due to mg. Second force is the force due to tension. See that two forces, they both are vertically downward toward the center. The direction is that vertically downward towards center. That means we can say that the resultant of the two forces is a centripetal force. See there, the vertically force, they both are vertically downward and toward the center. That means we are getting the resultant of that force is the centripetal force. You can notice here one thing, that tangent, the force due to tension and the force due to weight mg, they are not in the same line. They are at different point. By that information, we can write the equation for that. The force at point A, the tension is Pa plus the force due to weight mg. They both are given a centripetal force. That centripetal force help Bob to perform the vertical circular motion. So here we are getting these two forces are given the resultant centripetal force. So here m Va square divided by r. This is our first equation. Here you can understand Ta is the tension at point A, Va is the velocity of a bob at point A. So by this equation we can get the value of Ta. Therefore Ta is equal to, rearranging the term, Va square m into Va square divided by r minus mg. This is our equation number second. Now see that as a bob is going to perform the vertical circular motion below the point A, the bob, at point A, the bob having the minimum velocity. At point A, the bob having the minimum velocity, and below the point A, as the bob comes down, that time the tightness in that string is going to vanish. Otherwise, we can say the tension is going to vanish. When we are taking the example of a giant wheel, we are sitting in that giant wheel. When we are reaching at the topmost position, and when we are coming from that topmost position, that time the butterflies are running in our stomach. We can feel something is different. So here, similarly, when the bob is coming from position A, that time, so the tightness in that string is going to vanish. We can say the tension is zero. So this property we have to put in that equation here. If we are writing TA is equal to 0, so we are getting the value here, and VA square divided by R is equal to mg. From that we are getting the value of the velocity at point A. Therefore, VA is equal to, otherwise we can first of all write VA square is equal to RG, and finally we are getting the value of VA. VA is equal to under root RG. This is our equation number 2. So at position A, at the topmost position, we are getting the value of the tension. TA is a tension at point A, mv square upon R minus mg. By putting the condition, as the bob is coming below, that time the tension, we can see the tightness in the string is going to vanish. By putting this value, finally we are getting the value velocity at point A. VA is equal to under root RG. Now second we have to find out. Second is the lowermost position. The bob is going to perform the vertical circular motion. So here B is the lowermost position of a bob. At the position B, the two forces acting on that bob. First is the force due to the tension. It is directed vertically upward toward the center, and second force is due to mg. It is directed vertically downward. In this case, the resultant is the centripetal force. By this information, we can write the equation for that tension at point B. From that equation, we will get the value of Vb, velocity at point B, and the tension at point B. So that both the resultant of the two forces gives us the centripetal force. So here Pb minus mg is equal to m Vb square upon R. Here they have in the opposite direction. It is toward the center. It is away from the center. Vb is the velocity at point B. Now we can check the value of Pb. Therefore, Pb is equal to m Vb square divided by R plus mg. This is our equation number 4. See here Pb is the velocity at point B. We are getting the value of tension at point B. It is the lowermost position of a bob. That bob is going to perform the vertical circular motion. Now see there, when bob is coming from position A to B, that time the displacement is there 2r. Now why this? The displacement when the bob is coming from position A to B. Here I want to forget, but now I want to tell you, r is the radius of that circle, and also r is the length of a string. To that string, we tie the bob, and that bob is going to perform the vertical circular motion. See there, so here twice r, it will become the h. Up to that, we are getting the distance from point A to B, it is a twice r. See there, what happens? When the bob is coming from position A to B, that time the displacement is r. The displacement is twice r, so twice r is equal to h. Already I told you, vertical circular motion, which is controlled by the gravity, it having the special characteristics. In that, the gravitational potential energy is going to convert into kinetic energy. As the particle is going to perform the vertical circular motion, their kinetics, their motion is controlled by the gravity. That means when the bob is coming from position A to B, that time there is decrease in the gravitational potential energy, and that decrease in gravitational potential energy will give us increase in the kinetic energy. So putting these values, that formula, otherwise that information I am not writing here, just I want to write the equation here. Decrease in gravitational potential energy is equal to increase in kinetic energy. Here, decrease in gravitational potential energy from position A to B, from top to bottom, and that time there is increase in the kinetic energy from point A to B. So here we know that gravitational potential energy is there, that means it is given by mgh, but instead of h we are going to write here r. So here we are getting twice mgr. Here we have to find out increase in the kinetic energy. So the kinetic energy at point B minus kinetic energy at point A. So by putting all these values, we will get twice mgr is equal to kinetic energy at point B. Why this taken? We are counting the energy from place A to B. So it is initial position, it is a final position. So here we are writing 1/2 m vb square minus 1/2 m va square. See there, we want to simplify that equation. For simplification, we are going to multiply the whole equation by 2. Then what we will get? In this case, if we are multiplying this equation, it will be 4 mgr. This side, the 2 will come in the place of numerator and denominator. They both are going to cancel. So here what will be left? mvb square. Again here we are multiplying the 2, all terms of the equation. So here in the place of denominator 2 is already present. Then we are multiplying the by 2. It will comes in the numerator. Sorry, numerator, that 2 and this 2, they both will be cancelled. Then what will be left? Let me see. By the law of equal equation, they both are going to cancel. M is present in every term. So finally we are getting here Vb square minus Va square. And we are getting it is a 4gr. But if we are observing the equation number 3, in that already we are getting the value of Va. Va is equal to under root Rg. Then we are getting the Va square is equal to Rg. By putting this value, we will get finally Vb square is equal to 4gr plus gr, and finally we will get the value Vb is equal to under root 5gr. So this value we are getting, it is the velocity of a bob at a lowermost position. Already we find out the velocity of a bob at the uppermost position, it is under root Rg. Just now we found under root Rg. Here we are getting the value of the velocity of a bob at lower position Vb, it is under root 5gr. Now next thing is that we have to find out the tension. Just now we are finding the values of velocity at point A, value of velocity at point B. We are discussing about the velocity at point C and D afterwards. Now we have to find out the difference in between the tensions at point A and at point B. For that, the equations are necessary. So next is the special case is there. In that, we have to find out the difference in between the tension. So here TB minus TA, we know the value of TB, it is m Vb square upon r, equation fully right, plus mg, we have to minus the value of TA. TA is there here m Va square upon r minus mg. See there, this minus and that minus, they both will become plus. So we are getting twice mg. In the two terms we are getting the some common quantities. Let me take it outside. Plus sign will remain as it is. So here we will get m upon r, both are common. What is left in that bracket? Vb square minus Va square. Already we found the value of Vb square minus Va square. By putting this value in the equation, we will get twice mg plus m upon r. In bracket it is 4gr. R in the place of numerator and denominator both are going to cancel. What is the left one? Here we have to find out the difference in between the tension at point B and and tension at point A. So it is 6 mg. So we are getting the value of a tension at point B at point A. From that equation we can find out the value. Tension at point B is equal to 6 mg plus T. So in such a way that we are finding the tension at point A, at point B, the velocity at point A and at point B. Now let the two positions are there, at position C and at position D. These two positions are the horizontal position, otherwise we can say it is a midway position. At that position, two forces are present on that bob. The bob is going to perform vertical circular motion. First force is due to the tension. That force is directed toward the center. Another force is due to weight mg. Here mg is tangential to that force. So in this case, the resultant of that two forces are used to change the direction of the speed. In this case, we are not solving this directly. We are writing by mathematical calculation. We are finding the value here. Tc minus Ta is equal to Td minus Ta is equal to under root thrice Rg. And here, if we want to find out the velocity at point C and at point D, that velocity will become minimum velocity. Velocity at position C, it is a minimum. The velocity at position D, it is also minimum. And we are getting these values are there thrice Rg. Sorry, here it will be thrice mg and here under root thrice Rg. So these we are not going to calculate, mathematical steps doing, we are getting the direct answer. Now last term from that equation is left there, arbitrary positions. See there, I explain other terms from that diagram, but 2 points are left. If you are paying attention properly here, T1 and T2. That two are the arbitrary position. That means such positions are not under the control. See, in that position, if you are watching carefully, that the force due to tension and the force due to mg, they are not acting along the same line, and also the force due to tension and the force due to mg, they are not perpendicular to each other. In another cases, you can say here they are tangential to each other, but these two are the arbitrary position. Here, that mg is not perpendicular to the tension. They both are not the same line, they are different line. In this case, here the force due to tension and the force due to mg, they are not perpendicular to each other. So in that, the tangential component of that weight mg, only two pluses we are showing. The vectors, the resolution is there, mg sin theta, mg cos theta. Here the angle is different, mg sin alpha, and next one is there, mg cos alpha. See here, the tangential component of that mg, it is only going to change the speed of that bob. So these are the two arbitrary positions are there. So here, the tangential component changes the speed of a bob, which is going to perform the vertical circular motion. When the bob is coming down from A to B, that time the speed is going to increase. And when the bob is going from downside to upside, that time the speed of that bob is going to decrease. So here we can say that here accelerates, the motion is going to accelerate when bob is coming from A to B. And when bob is going from B to A, that time there is retards. That means the speed of bob is going to decreases. Such a way we are going to complete the vertical circular motion. Vertical circular motion is one of the example of a non-UCM. In that we found the value of a tension at point A, the value of the velocity at point A, the value of a tension at point B, the value of a velocity at point B. And here we are writing the directly these two values, the velocity at point C, the velocity at point D. In such a way we are completing the vertical circular motion. In next lecture we will see the next point. Thank you.